All right, hey everybody, I'm going to talk about charts from scratch in React. So first, a little bit about myself. That's me and my terrible family doing what we do best and failing to stare at the expensive professional photographer. I started my career with a bachelor's in molecular and cell biology, which naturally led to me being an animator for 10 years. When I got laid off, I was about 4 months pregnant with the little one in the green jacket, so I had to get another career really fast, so I went to a boot camp, and 2 weeks before he was born, I got a job as a front-end engineer at Pepperdata, where I've been for 2.5 years. So, enough about me. We're going to talk about charts. First, why would you want to do charts from scratch? Secondly, the overview of the browser drawing APIs that you would use for doing this, with some examples. And finally, I'm going to do some demos with code. So if you like to see code, that's going to be at the end. So the first question is, why build charts from scratch? There's a lot of great charting libraries out there. Why not use them? What are we, animals? We don't build our own cars. But seriously, let's take a look at all the possible use cases for charts. So if you want to build a chart, it ranges from very custom charts, very one-of-a-kind, doing what charts have never done before, award-winning New York Times infographics, all the way to very standard charts that fit the formats that we all know and love. So as far as very custom charts, you'd want to use low-level, powerful libraries that give you flexibility, like D3. Here's an example of one of those mind-blowing, super bespoke custom charts done in D3. This one's a visual introduction to machine learning. So as you scroll down the page, the data flows from one chart into the next in a really cool manner. This obviously took a lot of time and effort, and D3 was probably a great help in making this come to life. On the other end of the spectrum, you also have your very standard bar charts, pie charts, line charts, scatter plots. There's nothing wrong with that. People know how to read those. It's a great way to get information across. And if that's what you want to do, there are plenty of libraries that'll give you a template to do exactly the chart you want. All you have to do is plug in the data. Some popular ones here, Victory, High Charts, NVD3, C3. There's a lot of them that wrap D3. So what about this weird area in the middle where it says you might want to roll your own? Why is that in the middle? So the case where you might want to roll your own charts is if your concept isn't quite standard enough to fit into any of the templates for a high-level library. So you want to do a bar chart maybe, but it's not exactly a bar chart. There's no library that'll do exactly what you want. But you also don't need the power of D3. You're not going to do any fancy animation, and none of the math you're using is complex. None of the D3 functions will help you. Here's an example from our dashboard at Pepperdata. In both of these tiles, blue represents running tasks, and purple represents tasks that are waiting to run on the cluster. So on the left side, these are tasks running over 24 hours, showing those two quantities over 24 hours, pretty standard area chart done in D3, which helps make those shapes. On the right side, it's showing tasks running right now. So instantaneously right now, there's 384 tasks running on the cluster, and 225 of them are being run by user 42, who's a big resource hog. And in backlog, it's the same visualization. And there's a little gray funnel that shows that the backlog tasks will flow into the running tasks when there's room. So I think it's a pretty nice intuitive visualization. I might be a little biased, but the point is that there isn't a standard charting library out there that will do exactly this chart. So I did that from scratch in SVG. And again, the math obviously is not very complex. It's some addition and division, so there's no really D3 functions I need to help me with that. So no need to bring D3 into it either. A couple more benefits of rolling your own charts is it allows you to add functionality on the fly. No matter how good a library is, it doesn't do every possible thing. So if there's any kind of method or functionality you want to add that the library doesn't have, you either have to extend the library, or if you wrote the chart yourself, then you are the library. You can add anything you want. This is especially handy if your chart needs to interact with other parts of the page. So you need to pull some kind of state from the chart to light up a table or something on another part of the page. And if you roll your own chart, you minimize dependencies, because if you don't use a library, you reduce your bundle size by that much, and you also reduce your dependence on a third party to maintain a crucial part of your code. And when you roll your own chart, maybe you can just do it for fun, you can learn what your favorite library is doing under the hood, and not just let it be black magic to you. So you decided that you want to roll your own chart. How do you do it? First step is to get to know the browser drawing APIs. These are HTML, SVG, Canvas, and WebGL. Get to know their strengths and weaknesses, and we'll talk all about that. And then think very carefully about the use case for your chart. Think about what your chart needs to have. Is interactivity really important? Do you have a large volume of data you need to show? Do you have to draw some wacky shapes? Do you want to do groundbreaking 3D special effects and win an award and get prizes? So whatever your case is, you think about those two things, and then you got to choose the browser drawing API that will truly make your chart happy. Not the coolest, not the most popular, not the best browser drawing API, but the one that fits with your chart use case. It's all about compatibility. So the browser drawing APIs, they range from very declarative, using very semantic, human-friendly language, down to very imperative, more low-level, command-driven, and powerful and performant. So starting from regular HTML, it's very semantic. A lot of React users will be familiar with it. You can mostly draw rectangles. And then SVG is vector-based DOM elements, which allows you to draw shapes that are not rectangles, all kinds of shapes. And then you have Canvas, which is raster-based, so you draw with pixels. And then finally, at the very bottom, extremely imperative, low-level, powerful WebGL, which lets you do 3D. So let's go through all of them. Basic HTML elements. So we don't normally think of HTML as a drawing API, but you can draw. It's just mostly rectangles and text. But that's nothing to shake your head at, because a lot of charts are just rectangles. Like this timeline of our host reporting status page. So it's showing hosts on a cluster. When they were down, it's gray. When they were up, it's blue. The names of the hosts are on the left, and they're scrambled because it belongs to a customer. So it's pretty readable. You can see how it might be easy to do in HTML, just some text and rectangles. The only thing that was not so straightforward was the timeline at the top. So X, Y axes like that. They look really simple to do, but once you actually try to implement it, you find out there's a lot of gotchas, and sometimes it's worth bringing in a library just to do the axes for you. So the big strength of HTML is it's got first-class support in React. This is probably the thing that React works with the most users use it for. Interactivity and accessibility are a lot simpler with HTML because they're DOM elements. They're great at detecting mouse events on themselves. And accessibility simpler. A lot of accessibility tools are built to work best with HTML and its semanticness. And the text looks great because HTML was created to do text. Has a couple of drawbacks. So you can pretty much only draw rectangles, more or less. You can draw circles and triangles if you want to be creative with your CSS, but HTML is probably not the best tool to draw complicated shapes. And if you have a lot of data represented by a lot of elements, then thousands of DOM elements are going to choke the performance in your browser. So if you are doing a chart in HTML, some basics, you're going to use probably divs as the parent element, and to group, and the items that you're drawing. You can use, when you're using HTML, you can use percent widths. So you can put all your bars as percent widths, and then you scale the parent container, whatever you want, be super responsive, and they should scale with it easily. Or percent heights, depending on which way your chart's facing. HTML is great for rectangle-y things like bar charts, tables, heat maps, and histograms. You could probably do scatter charts, scatter plots and bubble charts with them if you use some CSS to make circles and use absolute positioning. Here's another example of an HTML chart. It's a timeline, again, of stages and a Spark app. And each of those blue boxes is a stage, and so is each row in the table. So as you hover over one of those, the corresponding row in the table lights up. So that's showing it's really easy to get it to interact with other React parts of the page that aren't part of the chart. The next browser drawing API, and the most popular one for drawing charts in the browser, is SVG, which stands for Scalable Vector Graphics. SVG is, you can think of a bunch of shapes that are also DOM elements. So you can draw very standard charty looking shapes like on the left in our dashboard, and you can also do fun things with it, like in this D3 demo by Mike Bostock on the right. You can do some physics and animation and interactivity and fun stuff like that. So SVG gives you the shapes. You can do whatever you want with them. Here's some SVG code. It's declarative. Here's some XML tag. You declare a circle element, give it some attributes, and presto, you have a red circle. So the big strength of SVG is each item is a DOM element. So it can be recognized by React. You can declare it in JSX, and React can keep track of all the elements, optimize updates, do all that cool diffing it does. The selection and mouse events are easy because they're DOM elements, so DOM elements can detect mouse events on themselves. Accessibility is also doable for this reason, but it's going to take some extra effort. You're going to have to add the semantic meaning. Like if your circle is a button, you're going to have to let your accessibility tool know the circle's a button. Text is a little more bothersome than with divs because you have to worry more about positioning, but it's less bothersome than it's going to be with Canvas, as we'll see in a bit. Again, SVG, the same thing that gives us this strength is also a big weakness. Because they are DOM elements, large numbers will cause you to take a performance hit. We'll see an example in a couple of slides. So first, when you're doing SVG, your enclosing chart container is going to be SVG, the big parent component. All of the shapes are going to be tags like rect, circle, and path. Path especially is going to be the heavy hitter for the complex shapes. You can describe pretty much any shape you want using a really long and often hard to read string that goes into the D attribute in a path element. And something important to note is that in SVG and in Canvas, coordinates start at the top left. That's where the origin is. So y equals 0 is the top of the box, which is the opposite of the way most charts are drawn. So you have to do some subtraction and stuff. So one reason you might want to do an SVG chart from scratch is you've got a complex shape and you want to turn it into some kind of bar chart or pie chart or something. So the arithmetic is pretty simple, just addition, subtraction, so you don't really need D3. It doesn't help you too much, adds a lot of code for no reason. And the shapes, you can just draw the shapes in any vector program like Illustrator, save it as SVG, and then you can open that file in a text editor and grab the path. So let's take a look at this rocket demo. Nothing exciting here, just you can push this button, and increases just to prove it's interactive. So here's the code. So here is this long string that is the path for the rocket shape. Down here, I got 3 path elements, and they all have the same rocket path plugged in. So they should all be the same shape. So how come they're different? Because there's a clip path here, and the clip path clips off the top at various levels. So you can get that blue and purple shape cut off. And then the clip paths themselves are declared here, and it's just your React, JSX math here, just some subtraction and stuff to show where you clip it off. So the clipping is interactive. All right, back to slides. So I mentioned that SVG has a weakness, so here it is. This is our charts page. And it's got a lot of charts on it. It's actually got a lot more charts than you see because you can scroll down. It's got a lot of charts. Every chart has a lot of time series. Every time series has a lot of data points. And we want each of those data points to be interactive and pop up a tooltip with detailed information about that specific data point. So in SVG, you do that by making every data point element on the page. So that's a lot of elements. In fact, when we initially tried to do this in SVG using D3, it took 5 minutes to render this page. That is why we went to a Canvas library. So Canvas is, you can think of it as a JavaScript-driven Microsoft Paint window because you draw with pixels like Microsoft Paint. When we did this with the Canvas library, the same page took about 10 seconds to render, which is a little more acceptable to most users. Canvas code is imperative. So instead of declaring the thing that you want to draw, like we did with SVG, you give it some commands about how to draw it. So here's how to draw a green rectangle, and you have a green rectangle. The big strength of Canvas, as you saw, is you can draw as many conceptual items as you like, because They're not stored as individual objects in memory. They're just stored as the resulting pixels. And as long as the number of pixels doesn't change, the memory for the display at least doesn't go up. So the same thing that gives Canvas its strength also lends a bunch of weaknesses. Because Canvas doesn't have any awareness of different elements after they're drawn, that makes interaction tricky. So you draw a circle. Later you ask Canvas, is my mouse clicking on this circle? And then Canvas will go, I don't know what a circle is. It's clicking on this pixel. Does that help? So there are actually some very clever workarounds to deal with selection in Canvas. But the thing is, if you're doing charts from scratch, you have to think about and implement that workaround. It's not going to implement itself. Canvas draw commands are imperative, as you saw, so nothing inside the Canvas element is a DOM element. It's not recognized by React. So you need to manually track the state of everything going on inside the Canvas, and you need to handle when it's going to render and update. Text in Canvas is just pixels, so your browser doesn't know it's a font, and your OS doesn't know it's a font, so there's no font optimization. Font often looks blurry. So a lot of people who do Canvas charts use HTML to put the labels on, overlay. So coordinates, remember, also start at the top left. There's no XML tags in Canvas, except for the outer Canvas element. So there's no JSX. So instead, to draw in Canvas, you can use React component lifecycles to run the Canvas draw commands. So maybe component will receive props. I used render in my examples. Or maybe component will update. So you can use components to totally abstract it if you want. So anything that consumes a Canvas component doesn't even know it's a Canvas component. So you can build libraries of Canvas components that other developers on your team that don't know anything about Canvas can just consume without even knowing Canvas is going on under the hood. Or if you really are excited about Canvas, you can create a React custom renderer that renders to Canvas, which there are a couple that exist. You can create one that meets your custom needs, though. So I'm going to show a demo of when Canvas is good. Okay, so here's some fake data chart about rain and temperature over some zip codes. You can sort it, and you can navigate with this MINIMAP. So there's like about 20 in this visualization on the right. There's tooltips, it's interactive. Text is important to be readable, and the only shape that needs to be drawn is rectangles. So what API do you think I used to draw that? HTML, right, so that's the best one. And then this mini-map could potentially have thousands of rectangle shapes in it. So what do you think I would use to draw that? That's Canvas. Yeah, so this has about 300 rows in it. I'm going to bump it up to, how about 5,000? So now there's 5,000 rows. Window's a little harder to grab. A lot harder to grab. I will get it. Got it. So, but yeah, the performance is not any worse. So Canvas is cool. Like that. Canvas is not perfect though. So as far as that window goes, how do I know when the mouse is hovering on the window? I can't just put in onHover on that window because the window doesn't exist. So there is a mouse event that can trigger on the Canvas element, but it'll trigger anywhere on the Canvas element, whether it's on the window or out of the window. So I had to do a little math to determine how to move that mouse around there. Final web browser drawing API is WEBGL. I like to say it stands for web good luck because it has a really steep learning curve, but it really stands for web graphics library. It's very low level, very powerful. You can do some cool things with it. I don't want to blow it off by any means. Here's a demo of some airline routes all over the world. And when you select an airline, the routes light up and the globe spins around. So WebGL can be useful for data visualization if you've got the right idea to apply it to. So the big strength of WebGL is you can pretty much draw anything that you can imagine in 2D or 3D. It's very performant, utilizes GPU when possible. It has a lot of the same drawbacks as Canvas as far as selection goes because there aren't any items, it's just the rendered pixels. And on top of that, if you're selecting something in 3D, you have to translate the 2D mouse position over the canvas into the apparent 3D position in space, which is a lot of fun. It could be very challenging to just draw in Canvas or in WebGL. Even if you're using an abstraction like 3JS on top of it, which I recommend, the abstraction is already pretty low level. So, but I don't want to discount WebGL. If anybody wants to use it for a project, that's really cool. Just make sure you budget enough time to get up to speed. All that being said, WebGL is probably overkill for most common cases of doing charts. But if you want to do a bar chart in WebGL, it'll probably be the best performing bar chart that you've ever drawn. So here is a demo of some bar charts that don't use WebGL. All right, so there are 3 identical appearing bar charts. Just going to click this button to show you it works. So except the top one is done with divs and HTML, the second one's done in SVG, and the bottom one's done in Canvas. So I'm going to do a quick inspect. The container, the parent container for the div is div. I know it's hard to read the tooltip. I'll just read it to you. Each of the rectangles is a div that I can hover on. The parent container for the SVGs is SVG. Each of the rectangles is a rect element. And parent container for the canvas is canvas. And each of the rectangles is, oh no, I can't select the rectangles. There are no rectangles in the DOM. So if I select this rect in SVG, the parent container is SVG, and you see these 4 rect children. If I click on the canvas, it doesn't have any children. It's like canvas is as far as the element inspector knows about it. So let's take a quick look at the code. So here is the bar chart page, and these are the 3 bar charts, and they're the same component. The only difference between them is this type prop, div SVG canvas. So let's look at bar chart, and what does that type prop do? It just selects what's going to be the chart and bar component, which here's the lookup table, and here's where I'm pulling the files from. Div chart, canvas chart, etc. But no matter whether it's the div chart component, SVG chart component, or canvas chart component, they're all called the same way. There's this chart wrapper, and then there's a series of bars, and they all have the same props. So whoever's consuming it doesn't really care where it comes from. So let's take a look at those components. How do they do that? So the div chart component, it's a wrapper. The parent component is a div. Each of the bars is a div, and it's positioned using absolute positioning and the color. So if we look at SVG, the outer element is SVG. Each of the children bars returns a rect, and it uses top-level props to position it. And canvas, so the chart. The outside is canvas, and one more thing has to grab a context and pass it down to the children. The children, in the render, they return null. So how does it appear if it returns null? So instead of returning elements, React elements, it runs a series of commands to actually draw directly to the canvas in render. I don't know if render is the best place, but there are a number of lifecycle methods that can be used. So back to slides. So again, here's the top level bar chart. It does not care what component it's consuming. It treats them all the same way. But the bar render methods are where the big difference is. So you got HTML returns a div, SVG returns a rect, and Canvas returns nothing, but it does drawing. So let's look at something a little more complicated than rectangles. You're probably sick of rectangles. How about a real chart? So here's some lines done in SVG and Canvas. Again, if we inspect the canvas, there's no children. If we inspect the SVG chart, it has one child, a path element, and there is the D string. Looks complicated. If we look inside both of those elements, let's go straight to the line. It works just like the bar chart. So SVG, all this calculation is done to get the points, and the result of all this calculation is a path string, and that gets plugged into this D attribute. Meanwhile, Canvas does the same calculation, but instead the calculation gets fed into a series of commands. So they look really different, but are they really? They actually use a lot of the same method. Here's an example of how SVG versus Canvas paths work. So you take a series of XY coordinates. Here's 3 points, 1, 2, 2, 3, 3, 1. So how would you render this line described by these 3 points in these 3 APIs? So in HTML, don't draw lines in HTML. SVG, you do a path element. The D string would look something like this. And Canvas has a bunch of commands. So they look really different, but actually if you take that string apart, the first command in the string is capital M means move to. That means go to this coordinates and don't draw anything while you're moving there. Then the next one is L, which means line to, which means go from where you are to this coordinates, this point, and draw a line while you're going. And then finally you draw a line to point 3, 1. So Canvas actually, after you begin the path, you also do a move to command to point 1, 2, and then you do line to the other 2 points. So it's really similar concept. It's just declarative versus imperative. So let's sum it up. The chart drawing approaches by API, when you're doing HTML, the items that you draw will be mostly divs. When you draw with SVG, you'll have a couple of custom tags and path, rect, circle, path. In Canvas, the items you draw don't really exist. You have to invent a scheme for them, track it in the state, and a way to draw it with commands. Same thing with WebGL. Best things that HTML are great for is rectangles. And its weakness is it can only draw rectangles. SVG is great at interactive shapes, any kind of shape, and you want interactivity. SVG is really great for that, and animation. Its weakness is there's a limit to the number of shapes, and I mean like scale, like thousands of shapes. I don't mean like you can't have a triangle. The Canvas is great at doing lots of items, which SVG can't. But the weakness is that the mouse interactions are really tricky. It's not automatic. You have to manually work on how the mouse is going to affect it. And WebGL is great if you want the best performance and if you want to do 3D. The weakness is hopefully you have a couple of weeks to learn it before you have to implement it. So as far as working with React, HTML and SVG work exactly with React in the main paradigm that people are used to working with React. It plugs right in. You can declare it in JSX. And Canvas, I don't know, a lot of people might think it doesn't work with React, but it does. I mean, that's what all the lifecycle methods are in there for, so you can do other things that aren't just returning JSX. So you can use the lifecycle hooks, and you can write a custom renderer for both Canvas and WebGL. So I haven't seen many WebGL custom renderers. That would be cool to see. All right, so that is it for me. Thank you for listening. Thank you for having me. Here is my contact info, Twitter, and email.
All right, thank you, Christina.